Good morning. Hmm. Today we are going to work on CUDA and compilation stuff. The goal here of the day, well, there are a few different goals, really. Hang on a moment. Welcome, Carlos. Couple goals for today, really. There are kind of two sides to this, right? There's the CUDA environments bit, and then there is the torch compile bit. All right, so we have this profiling bit from before. What's your opinion on Rust? Hate it. Hate the language. Especially, you can make an argument, like, you can make a decent argument for embedded system stuff, but for, like, the stuff I'm doing, it's just completely stupid. Makes your life a complete pain in the ass to protect you from a relatively small class of bugs that, like, are not even really major problems. Okay, so we have this profile test. JAX module. What do you mean JAX module? Just JAX versus Torch? For the stuff I do in RL, with one possible exception that I'm looking into at the moment, it's pretty stupid. JAX forces you to write absolutely terrible code because, so essentially there's this decision that was made that it makes it easier to implement a library like JAX if you make an assumption that's not technically required by the hardware and that makes you write terrible code. It gets a bit more detailed than that, but it's just, I have not tried, to be fair, I have not tried to write PufferLib quality code in JAX. It might be possible, but it definitely gets in your way. At the moment, I'm trying as hard as I can to keep PufferLib in Torch because it's just a better overall library with more users as well. The only thing I'm not entirely sure about with Torch is the compile times for, like, if you're trying to compile large chunks of code, the compile times are starting to bother me. The only thing I'm not sure about yet. I've run a few perf tests, and so far I have not, like, Jax does not seem to be faster asymptotically or anything like that. Tinegrad's cool. I probably don't agree with all the technical decisions, but it's an awesome project overall. There's not really any reason for me to look at it yet, though, because so far their NVIDIA backend, they say, is like a few times slower than Torch. And it's going to be a couple of years before they catch up. Because it doesn't force you to write terrible code. Like, go read any Jax code. It's terrible. It's like the worst aspects of functional and object-oriented programming blended together into something that's somehow even worse than either. So this is still not good usage right here, right? You get to 44 T-flops. Well, okay, hang on. If we model the hidden size... What if I do input hidden... What do you think can make Puffer catch up? Gymnasium is a way older project, dude. And Gymnasium's not even a training library, it's a frickin' spec that, like, everything uses. Puffer is the fastest growing RL library as far as I'm aware right now. We're already doing it, man. Look. We have the chart on the website. It's literally just keep doing what I'm doing and keep shipping the next few updates. This is when I started working on it full time. If I can actually make this next update work, it'll make everything so much faster. And everything will just get so much better. It's going to be hard technical work. Hence the title for today. Mobile multi-agent systems. I have no idea what the hell that means. That sentence doesn't mean anything. Mobile multi-agent systems. Well, multi-agent... I probably have my PhD is probably the most multi-agent of anybody's. I don't think anybody's done anything like Neural MMO. I don't know what mobile means in that. Yeah. Perform an RL code injects. Oh, you're the author of that? So, Carlos, the argument basically for using Jax for training, in my mind, is defensible. The argument against using Jax for environments is that you just compare the code, like compare writing the code in C to compare writing the code in Jax, and it's always simpler in C. You just write arbitrary loops and conditionals, and it's even faster anyways. Because Jax is like, doing really heavily branching ops in Jax is no bueno, right? I am actually starting to play around with doing CUDA, just like pure CUDA, and see how that goes, because if you keep CUDA very simple, you're basically just writing C. And in fact, I might even be able to have it support C and CUDA backends with the same code. Yeah. So basically, yeah, the main beef I have with the Jax M's thing, Carlos, just to put it clear, is that, so what happened, right, is that RL was doing all this work on like Atari and stuff, and I spent multiple years trying to push the field of RL towards more complex and interesting environments, and we got a few of them. But then Jax pushed it back the other way, so for the sake of performance, you have these M's in Jax, but then because the M's are in Jax, it's really hard to write complex environments. So like you get Minotaur and stuff, which are these super, super simple dumbed down environments, and that just kills the field, right? Because like you can't just revert RL to simpler tasks, right? Then everybody just stops caring. You need to go towards higher perf and more complex tasks. And the way to do that, at least what we've found so far, is you had to rewrite the vectorization stack and everything to actually support like not dropping your performance. But once you do that, you can get stuff running super fast even just on CPU in really simple code. Swarm robotics. Well, no, we don't have good environments for that, Ronaldo, but like you can write an N for that or port an N for that to Puffer, and our trainer will be better than anything else out there because nobody else has a remotely as fast trainer as Puffer. One train agent against past self. How can it load predispose? At Spencer or at like Lionheart or whatever his user is in the Discord. He's working on that now. Neural MMO is a swarm though, yeah. So it's just that's purely just like yeah, we haven't bothered to port like a specific swarm robot. Actually, we do. Technically, we have a drone env. Yeah, wait, we actually we have multiple drone envs, and there are a couple guys in the Discord that are running it on like real hardware now as well. So I take that back. Yeah, we totally do. We don't have like quadruped or whatever, but you know, go ahead and make an env. It'll work. Is it available right now? It's got to be a public dev branch somewhere. He said he's going to try to have a working implementation by this weekend of it. So the thing is, it's a bit more complicated than just loading an opponent, right? Like, he's trying to do the thing from the Dota paper. Yeah, Spencer. This is 83. Let me just see how high this goes real quick. $139. Okay, interesting. The heck just happened? There we go. Easiest workaround for that if it's still not available. You just like hack the PufferL file, right? Our trainer's a single file implementation. You just modify that to load in like an extra policy for the eval loop. You'd probably want to like make sure that the vectorization is not doing like double buffering or whatever. You can just predict the agent indices. 55 T-flops. Is this right? 155? What are we supposed to be able to get? This is 82 in double. Oh no, 82 in float. The wiki article. They have the chart. And they do. Okay, so single. So this says this gives us like the 80. Where's the sheet? Oh, here. Okay, so 165. Let's see if this changes it. Welcome, everyone. I'm playing around with a little bit of profiling, and then we're going to try to apply some of what we find to the trainer. $150. Okay, so it is the same here. So we are getting basically this number, right? We're getting the FP32 accumulate number. Why are we getting this number? Does anybody know where, like... I guess the easiest thing would just be to try to, like, crank everything up and see if we can go higher, right? Get rid of the relos. This will lag me a bit. Hopefully I don't OOM it. Okay, 157. So we're definitely getting... Oops. And I gotta not keep doing that because that dropped my OBS for a second. But, so we definitely are stuck at that number. I don't know why they give you that, like, why that's your master's thesis project if you don't already have experience in that. Because, like, you're gonna have to build something, and that's gonna be a pretty sophisticated sim. It's like you either have to know what you're doing and build something, or use something existing and spend a really long time fiddling with it. Yeah, so we're getting this. Interesting. Oh, I think that Torch has this disabled, right? Yeah, there is something about Torch being weird with this. Yeah, the thing is, Pi Bullet's basically useless because of how slow it is. So yeah, you can use Majoko or Pi Bullet or one of those, and then you'll get something that's too slow to be useful. Or at least, like, at the least too slow to be reasonably useful, right? A lot of people do research on really slow M's, and the sad truth of it is you just waste years of your life, like, waiting for shit to run and not being able to do your experiments fast enough. Trust me, I know. So, jacks for M's that are naturally just straight array operations. Like, if you are naturally just doing physics ops that are very easily expressed in pure array manipulations, that's actually not bad. It's like branching logic, typical conditional and stuff in Sims where jacks gets to be dumb. Allow. Wait, if reduce precision, intermittent, and single precision. View truncation. Matter. Cool. Get some cool people in the chat. That's fun. Has anybody actually ever seen a 4090 get the expected single precision? Okay, so I mean, it looks to me like at least we are getting the expected. We are at least getting the expected 16-bit with 32-bit accum. That is something. And then if I go back, what is this? So 128, down from 157, what do we get? Oof. We lose half of it. Is this a batch? Wait, can we get this with like 32? Can I get around this with batch size? Physics is just an array with minimal logic. Yeah, then Carlos, that's totally reasonable. You can do the same thing with freaking torch tensors then. Right? Bit irritating, but this is at least way better than before. Hey Jess, we're doing perf stuff. Okay, so yeah, this was the torch end that we have. Did you compile it, Carlos? Because Jax is like default, you JIT everything. Torch, you actually have to use compile for stuff. Because Torch has a lot of optimizations for eager mode to be at least pretty good. Compiled. Interesting. Because I've been running like perf tests with Jax, and it doesn't seem like it's better. Also, you don't have to write the environment in the same language as the trainer either. You can pass tensors back and forth between Torch and Jax without having to copy them off device. Just a cast, pretty much, I think. Test model wasn't learning. Speedy pointer nets. Ugh. You're gonna have to just go profile what part of your thing is slow, Jess. Like, how many actions are you giving it to choose between? Like that. What's wrong with this? Tech forces. Carlos, I am pretty excited in general about like material science plus RL. 64 you should be able to make decently fast, I'd imagine. Okay, so this is... Yeah, something's happened then with my install. Yeah, this is new in, Yeah, this is the new Torch version. That's weird. Inductor raised. So Jess, we want to fully compile the train loop, and we're also going to try what happens if the env is CUDA. Looks like this is a new torch bug. That's basically what we're gonna try to do, Jess, actually. But that's not the hard part, believe it or not. Like, the coup de env part is gonna be annoying, but, like, I'm very confident I can make that stuff work. The annoying part is actually the compile stuff. So if you all want to help me with that, be my guest. Let me use the restroom real quick, and then I'm going to get my first set in for the day. Since today is hard programming day, today is also hard deadlifting day. Oh, man. Holy hell. Hard set. That's 355 for 5 raw, though. That's not bad. Probably just do triples for the rest of today. I got my my set of 5 in. I'm happy with that. Whew. If you do not do heavy deadlifts, pretty hard to get that exhausted with seemingly so little work in just about any other way. Man. Okay. Alright, what's going on with this? Why is standard Blad Alec bullshit? Um actually 5 is pretty high up there, right? It's gonna be like plus 10%, no? 400. Okay. So that's pretty close. I don't actually want to do a 1RM, but that should in theory be pretty close to 4 plate. So then the goal will be like, I probably need to be able to triple 405 in order to be able to 1-rep it like comfortably without it being max effort. My best was when I weighed like 187, so that's almost 20 pounds heavier than I am now. My highest absolute weight was 410 for 2 reps. That's with belt and straps, though. Okay, what... Can somebody, like... What's going on here? I had this working before. Was I doing this on Puffer Max? I don't think I was doing this on Puffer Max, right? You know, I wasn't doing this on Puffer Max. So something's got screwed up. That's the right torch. Back end inductor. Well, now this is obnoxious, isn't it? What version of Torch do I have on the container? That's a good thing to go check. Because otherwise we're gonna get stuck doing dumb stuff for a while. I see, so it just has CUDA 12.8, so this will actually grab recent version. Cool. Here's what we're gonna do. Next little bit here, I'm going to build out a miniature version of the puffer train and Ford loop with the LSTM, and I'm going to see if I can get that to compile. That's going to be the goal. Yeah, that's what we're going to do. Where's my music? And then we will try to get in probably 3 deadlift sets. Maybe I'll do 3 or 4, and then I'll do some accessory. Those are the 2 things for today. CUDA, compile optimization. Get my deadlifts in. Okay, this is the module. Welcome, Triard. Okay, so we'll just do... What are you doing? Would love to get an elevator pitch. Yeah, one sec. So, those are two different questions. So, PufferLib is a very fast reinforcement learning library for RL. The project as a whole is just my comprehensive effort to fix everything that was wrong with the field when I was a PhD student. We have training up to millions of steps per second. We have ultra fast environments. We've made it really easy to write fast environments. We have better hyperparameter tuning sweeps. We have better learning algorithms. Just tons and tons of general advancement. We do a few things professionally as well. Puffer is a private lab, but all of our stuff is free and open source. And what I'm doing at the moment is I'm working on the next version of the library, and I'm working on some pretty serious performance optimizations because Puffer is already way faster than anything else out there, but if you do the napkin math, like, we're nowhere near as fast as you should be able to get the hardware with a fully optimized implementation. So my goal is to get within some reasonable factor of what the hardware can actually output in the next version of the library. And to do that, I have to fight Torch pretty heavily because I am optimizing training for much smaller models than people typically bother to optimize stuff for. So there are like a ton of additional layers of stuff that I have to deal with for that. You know, people always talk about how difficult it is to perf optimize large models. You have the exact same thing when you try to perf optimize really small models. What are you running on to get? What are the GPUs behind you? Well, what I'm running on right here, this is a desktop with a 4090 in it. And then behind me are, you can see there's a row of desktops, each with a 4090 in them. We've got a couple multi-GPU boxes with several 4090s, and then there's one box with a 5090 in there. As for what, but that was it, what are my jobs running on? What am I running on? I'm running on coffee. Well, the complete answer would be coffee, hard style, and deadlifts. But that's a little over the top, yeah. Well, it depends what you mean by large, try hard. Like, RL really does not scale the same way with model size as other stuff does, especially if you're measuring by the right thing. So, like, our models are typically anywhere from 100,000 up to a few million parameters. It's a little bit tricky because, like, if I wanted to optimize stuff for 20,000 parameter models, I'd have to go even crazier. Like, at 20,000 parameters, you shouldn't even be using Torch. I think that's a little bit excessive right? Like, I don't think it really makes sense for us to try super hard to optimize stuff below, like, 128 hidden dim, basic, like, 100k parameter models. But it is actually meaningful to optimize down to, like, the 100 to few hundreds of thousands regime, because you can do a lot of research in that regime, and stuff needs to be fast, because basically the difference between having stuff optimized and not optimized at that level is you having to wait, an hour an hour every time you want to run a full hyperparam sweep, or like it's technically feasible that we could get hyperparameter sweeps down to like minutes, right? You can imagine running several hundred experiments in just a few minutes. That would let you do dramatically different and better research. Oh yeah, but the thing is, like, greater than 500 mil. Do you know how big the Dota model is? The model that beat Dota, or top pros at Dota, is 168 million parameters. RL just totally does not scale the same way. Like, most valuable problems out there, most like RL problems out there are way simpler than Dota. And it's mostly a matter of how do we just make RL stable enough to solve them without needing a world-class team and like 2 or 3 years to work on the problem. As well as like thousands of GPUs. Jax Marl, yeah, Puffer's faster. Jax is generally bad for ENVs. Also, the Jax code is just awful to deal with. The only reason I could potentially see this having to be done in Jax, what I'm doing here, if I discover that there is truly no way around Torch compile times being as bad as they are for full loop compilation, then I might have to go to that. But we will see. Yeah, it's kind of funny how Puffer is literally Puffer in eager mode, like Torch eager mode, is faster than everything else out there. Except for like a couple single purpose, really niche libraries. Heck is this? Totally different thing, try hard. Like, RL on LLMs is like baby mode. The interaction problems they're solving are like, they're hard problems, but they're not hard because of the same reasons that make actual RL problems hard. Like, go try to make an LLM play Dota. Like, we have very, very clear empirical evidence that if you have fast simulators and you have a ton of compute, like, the sizes of models that you should expect to want to be training with RL are just tiny compared to supervised learning. Yeah, we do basically everything in RL but LLMs. Like, RL is a very large space outside of LLMs. In fact, I'd argue it's the more interesting space because you basically can't do anything with RL on LLMs unless you're behind closed doors in a lab with a ton of GPUs, where we can do awesome research that can go straight onto products, straight into scientific research in other fields and stuff, and we can do it at home. We're not compute constrained at all. Thanks for the talk. Thank you. And keep on this Optim. I will admit, though, Torch Compile is very, very obnoxious to deal with. But you know what I bet it is? I bet it's this stupid thing. I bet it's literally this. No? How about this? Mm-hmm. Oh, you know what this is? Damn. I bet it's this. Ta. Alright, that's weird. Okay. Your plan with RL. Let me explain this. So, basically, my plan is one, make cracked out RL so that our RL is basically not this janky thing that's kind of fiddly and takes a lot of tweaking, right? So get really stable, sane RL with good visibility, good analytics, good automatic optimization, all that. And then basically co-adapt a material science sim to be better suited for RL. You know, you wouldn't design a sim the exact same way if it were going to be used for press button, see what happens versus for RL, and then try to start optimizing for new materials. And part of optimizing sim for this, right, would mean there's speed optimization involved with that. There's like what corners can we cut and still get good outcome. There's multi-level verification. There's probably going to be actually some. I have some ideas for modifications to the core RL algorithm that will require simulation level modifications as well. Take full advantage of. So there are a whole bunch of different things we can do with this. The idea generally, though, if you want to see like why this is a good idea, think of it this way. RL fundamentally changes the way that you think about and use simulation as a tool. That's the key. Because it's intelligent simulation, right? It's simulation that you can tell what you want the outcome to be and optimize for that outcome instead of just saying, this is a sim, press a button, see what happens. Hey, Major. Hey, Major. Oh, I just said hi. Yeah. Heck is this? Mm, it depends what you define a task as, right? It's mostly a semantic issue, right? I can tell you to walk and chew gum, and I can say walk and chew gum is one task, or I can say it's two tasks. Oh, no, it's discrete. We have a multi-discrete M spaces, but neural MMO3 is intentionally for simplicity. It's designed such that the action space is a single discrete, so it's super easy to use. What else? Healing loss. So Jess, we need more experiments. Whoops. YouTube music. Good. So we need to do more experiments. We have the whole like other dozen plus M's to deal with. But I kind of just the way that I work is I kind of just work on whatever I feel like working on any given day, as long as it's in the top few things that need to get done for the next release. And at the moment, I feel like working on this side of it because in my mind, 4.0 is going to be like major perf optimizations in polish. It's going to be the largest ever data set of RL experiments released, and then Constellation, the visualizer that lets you play with them and get some insights, and as well as like a write up with some cool insights we find. Um, and because at the moment I'm basically confident in the outcome of Polish, I'm confident in the outcome of Constellation and of the experiments. The only thing that's less certain right now, like pretty much the last couple remaining questions are around perf optimization. So that's what I'm working on now. Because as soon as I figure this out, then there will be no more outstanding questions for the rest of the update, and it will just be a matter of getting the work done. And then once that's done, right, then it's a lot easier for me to structure my work because then I just like, basically set up 2-week work blocks until it's done. Something like that. Whereas when there's this uncertainty, it's like way harder for me to pin down when stuff is going to be done, what I need to be prioritizing. So try to get that done first. Models and M's if you're gonna try to circumvent. We don't really care about backwards compatibility for trained models, though, because you can just retrain. M's and stuff, it's gonna be fine. Like we're not gonna go break ocean or something like that, obviously. And this is not really circumventing PyTorch mostly. Like this is basically just hacking on their compile to try to get the whole train loop to compile. It's kind of obnoxious because this is one of the things that I can genuinely admit should be easier the way that Jax does it. But then you have to use Jax, which is like gross. So I'm basically what I'm doing right now is I'm trying to see if we can at least get something good in Torch, and I'm doing right here. This is a standalone, like simpler version of Puffer's code, and if I can get this to work and the flop utilization and stuff looks good, we'll proceed with this. Otherwise, we'll have to have a hard think about whether the train loop needs to go to Jax, which I really would prefer not to do, but you never know. I'm still gonna say like 1 in 8 chance that this ends up having to go to Jax. I doubt it, but we'll see. Like eggs, but eggs are good. I like eggs. I don't like Jax. Ever had the realization you're eating eggs? What? What the fuck is that supposed to mean? You're starting to sound like a vegan. One of my favorite bits of trivia is calling someone a vegetarian in Chinese is literally an insult. Heck is wrong with this? Oh, can you not do this? Oh, there are more of them. We have a couple more PRs to merge later. Right now, there are 2 puffers in here. You can play with them. This one's funny because this one likes to hang out down low, but if you put a star in the way, it'll like come up to just not like it'll come up to eat it just a little tiny bit. But like if you put one down here, it's not gonna come up unless it thinks it has to like the other one's too close. Funny. 130 WPM? Nah, I'm not that fast. It's Super Maven. Da, 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 da. Yeah, like 90-ish. I get slowed down a bunch because I type very slightly wrong and I make errors because of it. 90-ish is about what I expect. Fun fact, when I first started to type, like everybody thought I wasn't going to be able to use computer because I typed 8 WPM. I actually learned to type playing MMOs. That was the only thing that worked. Why the heck is this not defined? Like, I'm confused. Oh, because you're dumb. That's why. There we go. Yeah, notebooks are awful. I actually am genuinely at a point now where I think Python hurt AI more than it helped. It's really just not a good like one. Python is not a good language to do everything in. It's just really not. All right, so this is still 0 T-flops. Not good. Um, Go is like okay from what I've seen of it. I'd take Go ML over Rust ML to be fair. The JIT is coming. They have optional typing in Python. It sucks. I don't want typing if it doesn't make it fast. Whoops, that's a slow benchmark. Very slow benchmark. How is it this slow? So, Carlos, the closest thing to that would be like Scython. Scython, but actually good would be nice. I'll say Scython is not terrible. Actually, Mojo started to get some of the typing, like typed versus untyped stuff correct, and then they like smuggled a bunch of dumb Rust and shit into it. But you basically what you want is you just want something that lets you get as low level as C and as high level as Python, like pretty effortlessly without having to go through an obnoxious binding layer and without killing compile times. That's what you'd want. But like in my mind, giving up some of the high level stuff is completely acceptable. Right? Like most of the high level stuff people just end up using it to write god awful code. So like there are a few things that I wouldn't want to do in straight C. String processing comes to mind as just being really obnoxious. But I'd be way happier being closer to that than closer to Python. Yeah, Jess. So Python, it was a decent intermediary, but once you have a good bind system, you're better off just writing straight C. Python has compile bugs. It has like annoyingly slow compile times. It's like a weird intermediary where you can't cleanly. It's like annoying to intentionally go low or high level. You're kind of always in the middle. And I didn't get native C speed out of it completely either. Look, in my mind, the language problem is just not going to get solved, and CUDA is basically C anyways, so you may as well just write C. Get this wrong or something? Batch side dummy. Okay, that's more acceptable. Okay, so something's wrong with B float. Lovely. But we can at least do this. Okay, so we get 30 T-flops out of this with compile. Without compile, we get... Let's see what a difference it makes. What this is. Tch. It's funny seeing stuff like this, because, like, I definitely am not. I get tired just like anyone else. And when I get tired, I crash hard. Oh, that's beautiful. Oh, that's beautiful. Ooh, okay, that's bad. This is not what we want, right? Not at all. Yeah, that's not going to be worth anything. Good thing we ran this test. So what's up with this? Try harder. Well, you see the problem, right? Like, we don't want to have tiny little T-flops test here. Hmm. Okay, 76 mil forward, though. Right, so this little net here, we are at 76 mil forward, and that's in eager mode. Compile on, well, without compile on, the thing is we can also just do, we can go BF16 without compile. Oh, eh? The hell is wrong with this thing? Ah, dummy. Okay, so that gets us some T-flops, yeah. Can I do compile now that I fixed that bug? Oh, okay, this works. So cool, we get from 39 to 56, right? Well, you couldn't sell PufferLib because that's an open source library. It would be Puffer AI, the company, which realistically would mean that they would want me to be involved because you wouldn't just buy the entity without wanting me with it. And then that would highly depend on, like, for what purpose, what terms, etc. It would either have to be, like, a big number plus I basically get to do what I'm doing now but much more effectively, or a really big number such that in a couple years I come back to what I'm doing now but much more effectively with funding, with, well, like, unlimited funding. But that's not exactly what I'm looking to do at the moment, right? The Miss and Hinton. Yeah, pretty much. Hmm. I guess we can try, make sure that doesn't change it. Never succeeded. That's actually, like, one of those crazy topics that I'd be happy to go spend a bunch of time researching, and I think I'm actually in a better position to figure that out than the top labs are. Like, that's, like, something you could very easily test in, like, a core RL setting, right? Or not easily, but you could test it. Script. Oh. Well, I don't know why it hasn't, right? But, like, you would go build an env where it's like a very, you build like a very self-contained env where you should actually be able to teach yourself more and more stuff more and more quickly. Hmm. Another thing that you could look at is like, you could argue it's possible that you actually do have iterative self-improvement in a sense, right? Like, because if you look at, for instance, so one thing that would be interesting to me to look at is if you take a look at like AlphaGo or Dota, and you look at their elo over training, right? When you add more computing, you get a log linear curve in elo, but elo is not linear improvement, right? Elo is exponential improvement. So if you were to actually go track like human player elo over time as well, right? Like, I wouldn't be surprised that you actually are kind of getting the expected thing. I think like you actually might be getting the expected improvement. And then if that is the case, then it's basically comes down to like the problem formulation or something in non-self play settings. Credit to search. Dota didn't use search. Okay, this is closer. Okay, that's pretty close then. But we still don't have yeah, read the Dota paper. I always tell people, if you read one paper, read the Dota paper. Fully, including the appendices. Read the paper. Like, you're crazy not to. Go do it. Hopefully it doesn't crash us. Eight. I think it's the... You could polish up the MOBA. Okay, this is quite close now to peak. Right, so we can actually get some pretty solid flops out of this. It's a Dota size model, by the way. 1v1 fighting game. Yeah. Yeah, talk to Spencer. Okay, this actually goes way worse slops, which is kind of funny. Okay, so 1024 is good. What happens if we do like hidden size equal 120? Like what happens if we do this? Or like this? Oh, hello, bird. That's the cutest thing. I have a little bird just like sitting up on my windsill. That was nice. I came to say hello. Okay, so this is where you get a big difference, right? Here, compile gives you a lot. Yeah, this one makes sense. Something like this. Try this. Hmm. Okay. That's a start. We have something to run. We keep optimizing from here. Man. What? All right. I'm gonna use the restroom and then another deadlift set, and then we keep going. Yeah. Yeah. coffee. Oh, man. Honestly, better than expected. If I get the third set of 5, then I can add a 10 for next week, which would put me at 365. 3 plates and 25s. Not bad. Hello, not Elon. Notelon. We're working on hardcore perf optimization, as the title implies. Or just directly says. Okay, so why is this so slow? Let's see. Oh, this is not even supposed to be, This is not even supposed to be slow, is it? The 2.17T? Man, let's do this proper, like. I gotta not rip open my finger again. Remind me next time I get up to get a band-aid. Oh, hey, this is... Oh, a third of this speed. But it's not compiled. Can we compile this real quick? There is still only fish as well. I will be merging in more of those PRs, so if you guys are looking for something fun to do for a bit, a little bit of RL, go submit a fish to only fish. Holy moly, that's a lot of SPS. That means it's skipping the entire operation, though. Holy moly. Works for me. What, Jess? Is it still smart enough to be... Oh. See if this does it. There we go. See what this is. Skips entire op. Still can't be 73T, right? Let me see what this is. Let me make sure it's not something weird. Okay, so this doesn't change it, right? Then something's wrong here. Okay. This is also not what we were expecting. What is wrong with this thing? Oh. There we are. Now this is exactly what's expected, which is 3x. And we do like this one. See if it's still 21. Okay, it takes a tiny little hit. It's good though. Then 18 down 2. Weird. Jess, I honestly might. You know what? So, wait, can I not, wait, this, go here? No? Low. That's funny. Hmm. Well, that's something. Why is this now suddenly... Does this really make this big of a difference that, like, this just doesn't work without compile? Seems like it. Except I can't do it quite this way, right? Yeah, I think I gotta do grad function of evaluate, right? Yeah, so let's work on that. Phone check. I am on Restream. Restream starts the broadcast to YouTube, Twitch, and X. As far as I'm aware, there's no way to automatically set the category through that. I'd have to go like for each platform and set everything manually every damn time. That's why I don't have it set. Yep. If anybody knows a platform I can just use that's easier, that does let me know, like set that stuff, great. But I don't have a better easy way to do it at the moment. Okay, so the main thing we needed to do with eval here is HC come in, right? And then we're not going to need this carry anymore, actually. Right? Because we're basically just going to take, do we do the same batch? Not do the same batch. Well, that's obnoxious. Okay, here's compiled functional. .81. And then this one. Ooh. A little bit of overhead. Interesting. But we're stuck with it. For now, at least. Okay, because now what we have to do, right? This is the tricky bit. So instead of grad function of model, We need grad function of... Yeah, so compute loss is fine, but it has to be... So this is functional call of evaluate. Okay, and then this is going to return logits and values. And then we're going to go take a look at what we have here. Params and buffers, hang on. Oh. I see, so there is a little bit of extra overhead. Interesting. Oh, I see. I'm dumb. You no longer need functional call. What you do is you just call evaluate. This is actually cleaner. You just do like this. So you only end up needing one functional call, which is actually better. So now what we do is let's see what this does. And we have no teraflops at all. Compile take forever. Ah, I see what happened. Grad function like this. Okay, so it didn't actually get it somehow. Doesn't help. Slightly better. This is yeah, this is like same flops now as before, right? What we would like. Well, good. I mean, the raw numbers aren't, but we're getting somewhere at least. Hang on, let me answer this. What end would you use for your self-improvement experiment, or would you build something custom? It'd be something custom. Let me think. What I would use. What I use. I'm honestly thinking if ELO-based ones are the best. I don't think so. You basically just need something with a lot of room for skill expression. It's like pretty self-contained. Hmm. Well, I'll tell you what I will tell you what I have for you here. That like, because I don't have a full answer for you. This is actually like it would be a research question. But there are a few M's that actually kind of do suggest that you get self-improvement, but not in the way that you'd want. Basically, there are M's where the score, like once you fully learn the task, your score just goes up very quickly, like in Duro and stuff like that. You get pretty much like a linear, straight up learning curve. And then there's stuff like Tetris or whatever, where basically once you start figuring it out, you can get an exponential learning curve. Even though for humans you don't really get the same, like it learns faster than humans in that sense, like asymptotically. So there are M's where we have like evidence that you can just learn really, really quickly once you start catching on. I think that the thing that's probably missing is having a setting that has like a high enough skill ceiling like that, right? So like if you were able to do this in like NetHack or like a really hard task where you get this just exponential once you start solving, you just full solve or whatever. But you have to think really hard about the task and whether that's even possible, I suppose. Um, yeah. It's a hard thing. It's a hard thing. I might want to add a few more plots to Constellation, you know? Like, I might want to add, like, some optional extra stuff. We'll see. Because I think what's important is to keep track of, the shape of learning curves over time. You know, I had this thing with Neural MMO where in earlier versions you got these, like, plateaus, and then it would, like, catch on and then plateau and catch on or whatever. And then with the new algorithm, it just, like, catches on and it's nice log linear. Changes in shape like that are important. Oh, the other thing that's useful, Jess, would be like having a pretty dang long horizon env where basically just having a very long horizon env where you kind of need to get to the end, like get to as far as you can, and then practice that little section over and over and over. And it's hard because you have to get all the way back to that section to get your one practice attempt in. An env like that would also be useful because there's some algorithmic stuff around that that I think could have better asymptotic perf if we were to implement. And that's kind of related. Yeah. Best answer I have off the top of my head. Um, maybe, maybe. I'm too bad at chess to think about that properly. No capture. Repeat move draws. Oh. Yeah, something like that would be decent. That's actually kind of a cool one. I like it. Hey, Burns. Welcome. Freaking compile times. Egad. Long compile time for loops. Fewer pieces on the board, the more valuable they become. Yeah. Oh. Oh, so probably you can do something with this. Huh. For TPUs. Does this not work for should be. Nope. Ah. $2.8. Come on. Two to 10. Oh. This does not seem usable to me. Point 8.1. Coup to 10 set. Yeah, why is it doing coup to 10? Oh. Weird. I mean, that seems... If I can get this to work, though, right? Hmm. Is this even, like, remotely mature? Super old. Damn it. Damn it, damn it, damn it. Can I not just do, what if I do this? Would I approach it conceptually? I really don't know enough, to be honest, but I would probably just, like, the only thing that you could like, okay, there's, like, polish and stuff that you could obviously do that's missing, right? But the thing is, I'd probably just do... I'd probably just do something dramatically lower level, right? Just basically, like, have a bunch of good kernels and have it be, like, dramatically more manual, dramatically more control, but you just basically, you have a bunch of fast kernels, you have a good way of figuring out quickly which ones to use for your machine, which is what this thing is doing, but instead of over the whole net, you know, you do it more, like, individual kernel level. I'd basically just do... I just shift everything lower level. Because honestly, what I'm doing right now, as a dev, this feels fucking terrible. Right? This just feels terrible. There's no way this is real, right? Give me 0 freaking grads. Anything. Okay, let's try something here. I want to try the corresponding jacks. Just to see. Funny thing I wrote, started script, the setup boilerplate may not see. Make file in RAM. Let's pipe your input into the main function. Heh. Yeah. Just doing hot reloads, basically. In like a super jank way. And almost nothing and wait, what? Do almost nothing, hoping for the best. Yeah. It's gotten better. This is at least this is just me fighting framework stuff. I'd have written it and say I could do something like this. I rewrote it and see. Yeah. No, you can still submit to OnlyFish. Alright, do we think Grok can port this thing to Jax just as a test? I want to see if it can. I'm not saying we're doing Jax, I just want to see if it's as much of a hell as, like, if the hell is as bad over there as it is here. Because basically, so here's the problem, guys. I don't know what to do with this, and this is the thing that I was worried about. So first of all, this shit is just, like, ignoring this entire loop. So I guess I can technically do... Let's do this first. Yeah, let's do this first. We'll just do, like, carry... And we'll just do, like... Okay, we'll see if that runs. Let me get my my deadlift set in. There's a restroom, get my deadlift set in. And we will see. The thing is, I think it's a really bad move to have to do shit in Jax, and I only want to do that if it's, like, absolutely freaking mandatory, and if I can make it not suck. I would way rather just figure out, like, a nice, like, relatively clean way to get clever with torch compile and call that a day. But, like, shit is not easy. Like, the GPU gets a certain number of flops. I want all my flops out of my GPU. I don't want 1% of the flops out of the GPU. Ready for another set of 5. man. Coffee. That might be all the deadlifts for today. We will see if I do more sets, but that's at least 3 sets of 5. Yeah, okay, so this bullshit thing here, right, is just completely screwing up, and it's like ignoring the graph. Good thing. Huh. Repost got almost as much engagement as the original thing, and his account is how much bigger than mine? 5x? Not bad. What's this code look like, first of all? This actually looks like relatively sane code. There are a couple stupid things here. But this is like relatively sane. Okay. So this compiled, but we know at least we can get the eager mode up. Yeah, so actually its compiled train loop is as slow as PyTorch's eager mode. So let's just do here, we'll do this compile. Probably helpful. So our ability to use. Wait, what? Burns, what do you mean in this? Like, what do you mean? Yeah, this is a graph breaking it still, actually. Oh, well, I'm honestly not really interested in investing much in, like, more LLM workflow bullshit. I honestly don't even know if, let's say by GPT-6 or whatever, I still don't know if I'm going to be interested in that. Like, I don't know, we'll see. Okay, so this is, like, just slower, right? So this is basically what I keep seeing, right? Is that, like, Jax is not magically faster, and it kind of just sucks whenever I throw stuff like this at it. Okay, it's gonna write me a new version, huh? 4 and 2. Yep, that's worse than before. Go back to compile puffer. What if I don't do max autotune and I just do full graph? Can I do this? I'm tired. Yeah, so this is slightly slower. I will admit the code isn't terrible, but like there's no point in if and like oh we compile everything if it's gonna be like slightly slower. Yeah. Like what the heck is this compile function even doing, right? Like this is what the scan stuff is for, right? Because it's the same friggin' graph. Yeah, and it gets it wrong as well. Annoying. Yeah, there's the lag. Does nothing. Does literally nothing. Let's see if I can just get any version of this shit to like... Do you compile fast? Oops, not you, not you. Yeah, you compile fast, but you don't do anything, right? Yeah. Mm, static. We want static. There should just be a way to explicitly define the freaking static graph now. Oh, wrong one. So this is interesting, right? So trace how do graphs work anyways? So it just is building up like all the operations that you do, right? It's like constructing a graph out of the operations. You just every operation you do is a node. And then backwards, it turns out you can do just by chain rule, right? Gradients, you only need to know each layer. You only need to know input, the function, and the output, and you can compute the gradients. So going forward is obvious, and then backwards is partial derivatives at each layer. So you're just going through a graph forwards and then backwards. Pad, dude. Pad. Pad to fix size. Let's try torch jit trace. Hmm. I see. Well, then why don't we just do we do like forward? Try this first, and then we'll do trace. Hello, welcome. Okay. This is something. What application? This is PufferLib. This is the high performance reinforcement learning library that I developed. It's open source, all the demos are here. I am working on some very heavy performance optimizations for the next version. I'm essentially fighting Torch because I'm trying to make really small networks fast, and that requires optimizations that you normally wouldn't think of. That's completely jank, but let's see if it works. Nope. Would AJ start coding? It depends how seriously. Somewhere between like 12 and 14, probably. If you mean by what age could I write something that wasn't like complete and utter garbage, like 17, 18? Okay, so this is fine, right? We do this. Okay, and then now 1.1, 1.5, right? I preemptively answered that preemptively. No, I'm good today. I was tired yesterday, but I'm good today. Okay, this is comparable, right? Yes, very comparable. So you get something like this. And then you have to compile both. Ah, okay, so this does actually compile now, which is chill. But that flops is a lie. Also improve larger models. This will improve all models, Jess, but it's to differing extents. I make money out of this. So Puffer is a private lab. Our stuff is free and open source, but companies can pay us for, as we have on the site. There's priority service. We do custom sims. We do contracted R&D and larger projects as well. Yeah, it's better to not even start entertaining the AI ethics stuff, because not because there aren't meaningful questions you can ask, but because like they're some of the dumbest people you will ever meet in that space. Like you literally have to see it to believe it. Like I distinctly remember sitting down at a dinner one time in SF and some guy unironically trying to like pitch shrimp welfare. Is like, well, there are a lot of shrimp, so if each shrimp suffers a little bit, then that's a lot of suffering. How can it how can it improve large Son of Liberty? This is just pure perf optimization. This is just like pure run the model faster. Let me see if I can solve my own problem in the meantime with this. Could it possibly? It can't possibly be that fast, right? They already improved. Okay, so this is not how research works, okay? You don't just you don't take literally the most stable, best tested chunk of architecture, write a couple of papers, and then say, "Oh, it's better in all applications." It takes a lot more than that. That said, I am going to be looking at XLSTM purely because it will play nicer with compile, but I'm expecting it to be a pain in the ass because research is never, ever as clean as it's written on paper like that. No, XLSTM is not just for LSTMs. there's a thing that you can do for normal usage. I think the only motivation though would be that it could play nicer with compile. That's basically it. I'm not joking. Like, the reason that you don't start the AI ethics thing isn't because of the content of, like, the topic, right? It's because you're going to be talking to, like, the most autistic, out of touch, insufferable people you have ever met, that, like, I don't know what they think that they are, but it's nuts. Like, it's unbelievably insane. It's like you see some shit in SF like that, and it's just like, run, get out now. Like I like autism and like social ineptitude doesn't even come close to being enough to explain it. It has to be like that, like really, really socially inept people, way more than me. I was the nerdy guy growing up too, all right? Like really, really inept people, and then like shit tons of hallucinogens until they fried their brain. That's the only thing I can possibly think of. Oh yeah, and then in the biggest echo chamber ever. That's the only thing I could possibly think of for how, like, the shit that I've seen there. Oh. Programming, making projects. Don't ask me for like standard employment advice. My stuff is very unconventional. If you want to know how to get good at the stuff that I do, that's another story, but that's a completely different question. I put out plenty of educational material on programming, ML, and RL specifically. But I am not the like I'm not the how to get an average job guy. Honestly, man, like, this stream here is mostly my replacement for that. That in the open source community. I have a few folks that I chat with every so often. Um, like, you know, that I know from AI that I speak with. But this is, yeah, it's tough to find those people, especially nowadays. Alright, why the hell are my grads 0? Grads should not be 0. I also don't particularly want to have deep conversations about stuff that's not, like, the tech I'm working on anymore, frankly. Like, most of the people in SF suffer more from too much thinking than from too little. Why the hell is this 0? Oh, is it? If I'm this dumb, then I deserve it. Apparently I'm not this dumb. Wait, unless... Hang on, I might still be this dumb. Well, it's not that. It's... I didn't understand how torch buffers work, to be fair. I'm trying to come up with own models. Trying to get that one. There really aren't good architecture papers in RL, though, is the thing. There really aren't. Yeah, but Jess, the crazy thing about that, okay, like, I am on a farm in the middle of nowhere in a warehouse with gym equipment and servers. So if I am more in touch than you, that is a serious, serious problem. Right? That's the thing that baffles me. Welcome to all the YouTube folks. We got a good number today. So to reiterate what I'm doing here, I am attempting to torch compile an entire training loop, like multiple gradient step updates, and I'm computing model flops utilization, and I'm basically trying to see how good we can get a small model, how fast I can get a small model to run, with the idea that I'm going to use this to like massively improve the speed of PufferLib overall. And Torch Compile is really not designed for this initially. Jax more so is, but then whenever I've tried to write comparable tests in Jax, it's easier to get the test to run, but it's not actually fast. Plus, I'd rather keep Torch if I possibly can. Just a better library in general. So yeah, that's where I'm at. Touch grass. I do touch grass, in the literal sense only. Why not you rest sometime? I do rest. I have a screwed up... I have a kind of a screwed up idea of rest, but I do rest. Last couple weeks, I literally have just lifted weights all day on Sunday. It's been good. Like, my folks were here, so, I did a bench session with my dad, had breakfast, I went outside and, like, lifted, I got a bunch of big boulders outside, so I moved those around a bunch, and then I came back, I did a ton of cable work, some ab stuff, and just, like, bunch of stuff all day. Listen to audiobooks, it's chill. 500k. I don't think 500k for cart pole is not impressive at all. And you're going the wrong way as well. Like, the expectation is that you're going to have bigger... The expectation, at least, is going to be that you will have bigger nets for a smaller number of steps. We have some decent empirical data for that as well. Alright, why is my grad 0? Why is my grad 0? I don't have a no grad on it. Okay. This is a good time to mention all my dev on Puffer. It's open source. It's here at puffer.ai. Or the GitHub if you want to help me out a lot. It's free. This really helps me be able to spend more time on this. Discord if you want to get involved with dev. We have a ton of helpful people in here. It's a lot easier to start on this than you'd think. You really don't even need much knowledge of AI, at least when you start. If you have a decent enough programming background, you're good to go. You can also follow me on X for more content. We're doing a kind of a funny little community event as well this week. This is onlyfish.ai. You can submit puffers to appear on this website. We've got a little toolkit. It's super easy to get started with these, so fun little first project in RL. I'm going to merge a few of these in later today or tomorrow. The goal is to have a whole bunch of different fish that play around differently. Still all 0 grads, huh? Yeah, they're literally all 0. Nope, just coincidence. Well, it's not even so much a coincidence as much as like it's got to be a weekday, and I typically make Saturday my long work day, and I need a break after that, right? Like I couldn't have Sunday be my long work day, um, and then like go straight into a full week of work after that. That's the main thing. All right, so for some reason this is 0. Zero grad. Oh wait, I see. Yeah. Yeah, I see it. Okay, that's annoying. I see why it's messed up, though. Yeah, it doesn't need as much computing power. Some of it definitely doesn't. RL's kind of awesome for that, right? Like, the number of problems we can solve in RL with models that run on a potato um, is pretty impressive. Now, the problem, right, is RL is not as mature of a field. RL has not had the type of investment that the rest of AI has. And it's actually kind of just a comedy of errors. I have some articles on this on my X tab, like my X articles tab, but pretty much there's no good reason why RL should be as unpolished as it is today, other than that we just completely messed up the engineering. So that's what I'm doing now, is I'm fixing that. And we've made a huge amount of progress in the last year and a half. I'm working on this next update. If I can get these perf enhancements plus the visualizations and stuff from the rest of this this planned update working, we should have the field in a really, really good spot just on pure iteration speed. And we'll also have the tools to ask the type of large-scale scientific questions that we've always wanted to ask as well. It's honestly already to the point now when I try to solve a new problem with RL, most of the time when it's like, oh, the RL is not working, it's because I have a bug in the simulator. Pretty much any relatively basic problem that I build a custom sim for, the RL more or less just works out of the box. Thoughts on bootstrapping? Nothing super major, Jess. Nothing super major yet. Use a restroom real quick, and then I will keep going on this. I know what's wrong with this code, though. Do I do more deadlift sets, or do I start on something else? I think three heavy sets of 5 is pretty good for today. I think I will do... Let's do some weighted pulls. Yeah, let's do like some weighted pulls. I'll be right back. And then we'll get this working, and then hopefully we can get some reasonable compile speeds from this. Alright. 45 for 7, not bad. Each action to a sine wave. Yeah. It's cool stuff. You should look up the like the paper on solving Atari with six neurons. Need to come up with a reward function to make a pull request or recommit. So what you would do is, it doesn't just have to be a reward function, but that's like the most obvious thing to start with. You can change any aspect of training that you like, as long as you keep the observation and the action spaces, and then the network architecture. But that means like the training curriculum, like details of how the sim runs during train, hypers. You can change a bunch of stuff, and then you just commit me the model. So it's essentially just a playground for you to have some fun making an agent that's like cool to play with. And then other people get to play with the puffer online. We're doing the frickin' heavy-ass lifts today. I guess those are probably like the two most tiring things I do at the moment, other than, well, since I'm not squatting, right? Times it's 350. Yeah, so I think we'll just aim for the 3 sets of deadlifts, 3 sets of weighted pulls, and then some accessory. And we'll get this done. Start debugging this. I know what's wrong with it. It's the way we're doing these buffers here. I want to make a fish, then make a fish and PR it. A bit of orm. It's the same thing, boxing. But like, if you deal with it in the environment, then like I can throw my default nets at it and not have problems. So if I'm looking at it from the perspective of, do I want to make this end a pain in the ass to deal with? Just do it in the end, easier. Do make a fish. Only fish. Grinding hard on some idea. Same here, man. Hardcore day. I wanted only fins, but it's a Finnish dating site. You backed off the edge a little bit, did I? Wait, what? What did I back off on? Yeah. Or the .com was. I think I checked the .ai as well. Wait, did I get the wrong domain? Hang on. Yeah, taken. Unless I bought it and then forgot. I don't think I did, though. For Manning? What? Chris Manning or what? Or am I thinking of something else? Chris Manning is a professor. Fuck is this? Oh, whoops. Manning Publications? The fuck? Is this gonna be some... Oh. That's funny. Is this Chris Manning or is it unrelated? When you said Manning, I thought it was either gonna be the NLP thing or like... You know, some cringe how to be alpha thing. Yay, we have grads. Now I get to see if I actually need the no grad. Because I don't think you do, right? Because I think it computes buffers separate. Oh, you do? That's weird. Interesting. Yeah, it does 0 grads. That's annoying. Wait, that's freaking weird, isn't it? What did you make of this since last year? Oh man, a ton. Massive freaking amount. Are you kidding me? It's not the same field since last year with what we've done since then. We've got RL up to 3 million steps per second. We've got a nice big library of M's. We've got it so stable and consistent that if you make any new, like, relatively simple env, it has a decent shot of working out of the box. If it doesn't, you run a hyperparameter sweep, and then it almost certainly just works. We've made, like, triple, I think, progress on the harder environments that we have so far. We've simplified stuff a ton. We have, like, fundamental algorithmic advancements. And we've done a massive, massive amount. The project has grown, like, since November, like, at least 5x since then. And we have Kyung here, who is submitting us useful PRs. I'm going to trust you and insta-merge this, Kyung. I'm going to take a quick look, but insta-merge. Because I'm on track here with the new shit I'm doing. Actually, let me read your description first. Sweep error, okay. Final eval. Yep. Sweep failure, cool. Refactor downsample. Removed ABC, very good. No ABC. Did you do hard stop at... Okay, that's cool. That's actually sort of what I was thinking. Good. Thank you very much. Looks good. Thank you. Yeah, Kyung, I'm fighting Torch Compile right now. This is the Shock Cavalry work. Is this a bot? Is that like, or is that just the dumbest possible take? Don't make your code fast, because hardware gets faster. Lab shifting to RL. Wait, did I say lab shifting? I said shifting away from RL, didn't I? I said that it's like the most likely next bet if they're wrong, right? I didn't say that they're going to recognize that anytime soon. Though funny enough, it turns out that since I wrote that, they started throwing RL on their language models as well. Labs have not shifted to RL since last year. Like, actual RL. They're doing, like, stupid language model RL. So far, I have not seen a single useful innovation come out of LLM RL that applies more broadly. Were they right? No, they weren't right. Like, literally, they literally stopped doing what they were doing and, like, started doing RL even on their language models, right? And it's like they still haven't solved everything like that. They've had many billions of dollars poured in since then, crazy, crazy valuations. And we're still solving crazy shit that they can't do with like 100k params. Good feature specializing in RL. I could literally do anything I want within 2 months. I could be working on optimizing the hell out of like large language model training pipelines within 2 months. Like being good at general ML, having some domain knowledge that's pretty easy to get. Being very good at programming in low-level dev. Do what you like. The skills are pretty general. I'm not the person to ask about, like, traditional jobs either. Okay, so this thing ran. Wait, did this thing... What did I just do? It's not that the LLMRL is bad, it's just that, like, it's kind of subsumed the whole, whole discussion on all of RL, and it's, like... It's basically stupid baby mode RL that's just being scaled massively on a really valuable app. Which is the annoying bit to me. Making a perception machine more or less... What? Your low-level skills do a lot. Like, low-level's kind of the core of a lot of this. It's way harder, in my mind at least, it's way harder to be a good programmer than it is to be a good researcher. Like, research is relatively not that difficult. And, like, you're relying on your programming skills for all of it anyways. A lot of academia is just, like, bumbling around because of inadequate programming skill. Alright, the compile function is still insanely slow. Of much ML or RL. Well, check my guide, right? I have a guide on X that literally just walks you through step by step how to get into RL with projects. Terminate at frequency. I don't know what you're saying. Mutual. Yeah, being a good programmer is very, very hard. Very, very hard. Because, like, honestly, programming is as close as it gets to just pure thinking and logic in my mind. It's not like mathematics where you don't necessarily have mental models and abstractions always. Like, a lot of being a good programmer is ripping out the abstractions. I know, in my mind, like, programming is very, very close to just thinking. Okay, this compile function is, like, obscenely freaking slow. Is obnoxious. Hang on. Can I get rid of this carry now? Looks like it. What speed up would justify the compile crap? Well, it depends, right? It depends on if it doesn't mess up the PufferLib code, right? And it's just really hard. Then, like, if I get a 20 or 30%, that's actually worth it. I think I can get much more than that. What's this? If we do this. Interesting that it does that. .85. Interesting. Okay, so now we have approximate parity. That doesn't do anything. That doesn't do anything. That breaks it. Nine, 3, and 80. Okay, that doesn't do anything. Okay, that's intermediate compile bad. That is crazy slow. Why is Torch so slow? What are you looking at in terms of the compile times or the flops? It's slow in compile times because, I don't know, something stupid. It's slow in terms of flops because these are small models and it's kind of tough to optimize small models. And also I'm using a very small test because the compile times are so slow. There should not be that much seed instability. That much seed instability is kind of an artifact of earlier, shittier algorithms for the most part. And we do, we also, so what we do is we run large sweeps, right? So we run large sweeps, and then we will reevaluate the final hyperparameters. And if that gets about the same score as the original sweep, then it's good. Tinygrad looks very cool. It's going to take them, he says it's going to take them a couple years, though, before it's perf similar on NVIDIA hardware with Torch. Oh, slow. This is ridiculous. Nope. Don't change the model architecture. It makes it a pain in the ass to deploy. There's much more interesting stuff to play with than that, though, trust me. One off 20.6. Very nice. Okay, this compile is insane. Lovely. It's getting to be right CUDA kernels yourself a clock, but I don't want to write autograd of myself a clock. Niggle. It can see the cursor boxing. You can have it play with the cursor. You can like have it do tons of stuff. It can see stars. It can see other puffers. Make a fish that's fun to play with and watch. You will be judged on whether the fish is fun to play with. Interesting. Two three three 174. Here's the restroom. Get a set in. It's still compiling? You gotta be kidding me. They're ridiculous. So here's the thing with Go. The thing with Go is they use search, right? And they had a very optimized GPU implementation of search. And I presumably of the game. So like AlphaGo is actually the one project where like the engineering is relatively, well, not straightforward because implementing search efficiently is very hard. But the engineering was done quite well. And that's actually kind of hard to do. We're doing chess at the moment. Jess is doing chess. And my hope is that we're going to get like a pretty decent no search agent that you can just train fast with Puffer. We shall see. Star of the Puffer. Helps out a lot. There's growth in the last week. MCTS so complicated. Try to implement it fast and you'll see. Try to implement it fast for neural nets and you'll see. Oh. 462, 438. So that actually made a pretty dang big difference. Right? Maybe FBR. Huh. Okay, full graph makes a big difference. That's kind of crazy. No, that was double the perf from max autotune versus from nothing, like from regular compile. So from compile overall, we're getting more. Yeah, so from compile, that's 3x and 10x in inference and in train. But the compile times are really obnoxious. But this is still not good, right? These are still very low flops numbers. Like 5, the best we have here is 5% Not even 5% utilization. Ass. Oh, but you know what? No, this is gonna work. This works. Yeah, this is fine. So 462 was before, right? Okay, so you really don't lose very much with the Funk API. You lose a little bit with the Funk API, but not very much. This is 4090. Make sure there's not bullshit. Well, that makes no frickin' sense, right? Oh, that's almost as good. .72. The best. I'm just seeing if there's additional speed benefit from this. Eval can definitely go to B float anyways, right? I will say that at the very least, this is not terrible, right? Like what I've come up with here, like this is still good code. The grad function thing is very slightly obnoxious, but it's really not that bad. I have chickens outside my window wandering around. Compiling longer seek does take way longer. I've tried that. I don't think so. It's so right now there are two different problems, right? The speed of the compiled model and the speed of compilation. Okay, so this is the number we wanted. 4.97, because this tells us essentially, yeah, this tells us that there's nothing to be gained by making the seek length longer, which is good to know. So basically, we've squeezed as much of this as we possibly can. Why the fuck does that add so much overhead? Dude, tell me that's not cursed. Tell me that's not, like, completely cursed. That's stupid, right? What are you drinking? Olipop. It's like a 7 out of 10 soda that's not bad for you. And doesn't have sweeteners that kill my stomach. Okay, I think this is just differences in it finding different kernels. Oh, that's what it was anyways. So, okay, so we'll do this. Just to check this real quick. Six. Not very good. So not very good. Make sure this is not it. $5.46. Oh, that's a big difference from this freaking stack, isn't it? Can you do this? No, this is invalid, right? Just do like this. Oh, is this just variance? Yeah, it's just variance. Cool. What we expect anyways. Okay, 3.8. if I go to like, I want to see how far I have to go before it's optimal. Decent, but not good. How are we gonna train chess without search? You just train train a neural net to play against itself. Same as you do anything else. Oh? What's this? I guess it's just cached. Okay. Okay, so that's 38 T-flops. And then if we do like this size net, which is probably about the most we would do. $72. Okay, so that's about half of what we want. Okay, let's try float. Ooh. We'll try this. The hell is this? The heck is this? Weird. Hmm. What do we do? Doesn't seem like it plays nice with torch compile. Okay. No difference. Let me use the restroom real quick. One more set as well. We're making progress. We're making progress, but it's slow. Very slow progress. That is 6 heavy sets for today. Yeah. It'll be just accessory work after dinner. Variance here. A lot. Fixed environment. Well, then just like port your reward over and retrain it. Okay, we'll just do this then. Really? Sounds weird. Ugh. Mutated inputs, huh? Sets to the rubber duck. Sets are good. Lift heavy. Obnoxious. This. Okay, this is fun. Okay, there we go. 6. That's nice. Got inference up to something decent-ish. Because now we can do, like... 38. Okay, so I mean, this is like, we have some inference speeds here, yeah? Does it keep going? I'm curious. I see. Okay, so you still do get perf improvements from larger and larger. 46 to 38. They still got some perf enhancement. Go back to this. Okay, this is not bad. Oof, 250k. Hello, how's it going? That helps compile time a lot. Maybe we can do this regional compilation thing. Well, yeah, one cool thing you could technically do, right, is you could, like, change the rules of chess, and you could measure elo curves over time, and basically see if you can if you can find a rule modification to chess that actually, increases the skill ceiling of the game. That'd be pretty cool. Adding kill streaks to chess. $9.60. That's funny. I actually don't know what that does. Like to the game, I mean. And replace it with inference mode in the entire... What do you mean in the entire library? What entire library? I'm writing a... What I'm basically doing is I'm writing a standalone compile test that's like pretty close to the puffer setup and trying to get optimal flops. With this guy? Lol. This is kind of weird. I can't tell why this does not compile. Oh, you know, wait. I do this. Hmm? Yep, that's the term. PhD defense, welcome. This is fighting torch compile. We are fighting torch compile. That is what we are doing today. We got inference for a very small model with very small batch up to like 60 flops and up to like 40 with a reasonable batch size. And now I'm trying to figure out what the heck is wrong with what's wrong with this compile function basically. This is super obnoxious though. Come on. Super obnoxious. There we go. Okay, let's go from here, right? And let's try a couple things out. Okay, that's slightly better, right? So now we have the inner bit compiled, right? The grad function. So if I do 64 here, one loop, this should be fast, yes? The model should be compiled? Yes. And now if I start increasing loops, why is this not fast? Grad function is compiled. Okay. Dude, what the hell's wrong with this thing? Compile times are just so unexcusably bad. Inexcusably bad. So wait, you're compiling... Compile the whole model as well, right? Oh, I know why. I know why. Yeah, I know why. That's why. We're gonna make this work. Because this is just so incredibly obnoxious. You know? I got 15 minutes before dinner. We're gonna get something good. It makes me happy when It makes me happy when I make a tech take, and then I get people disagreeing with me, whose code I've read and I know is terrible. Maybe that's petty. But, like, there are actually people that have, like, almost a perfectly negative correlated signal. Like, I don't know. I know a handful of these people where, like, basically, if whenever they say something, you do the opposite. Like, it's actually a pretty good model. At least in, like, a specific area. I can think of, like, 5 or so off the top of my head. Yeah, the Jim Cramer index. That's funny. It's basically that, but for engineering. The Python type hint thing is so incredibly stupid. Like, literally use any other language. It's like the only good thing about Python. Alright. Is this thing just stuck? Well, here. I think this will work better now anyways. Use Python to bind jacks to what? That doesn't make any sense. Actually, that's a good question. Does Jax have a non-Python backend? Jax is written entirely in Python. Lovely. Uninvoked backwards? Really? Oh, I know why. Okay, so we do... Okay, super slow, right? We have PufferNet running on the drone? Where's the video, Finn? And I gotta get you your docs as well. Welcome all. I'm excited for this. Where's the video, Finn? Some of the models only seem to work in Jax. No, that's not true. I tried. The Jax versions work, but they're like not fast. Like they're as slow as PyTorch Eager mode. Not flying though. Ah, okay. You got me all excited there. Come on, man. Let's see. Let's see the puffer drone. Here we can make only drones.ai next, where we have a bunch of drones that fly around. Oh yeah, for if anybody who hasn't seen this, this is only fish. You can submit a puffer to the tank, and then you can play with them. All puffers that get submitted go onto the website. Very close. That's good to hear. I am suffering through torch compile optimizations, so I'm glad that you're having some fun. at the very least. Jax is not a lot faster from anything that I've timed. It's a lot easier to get the Jax compilation to work with stuff like this, but then it's like still slow. So what's the point? Uninvoked backwards, huh? Dang. Well, this will be the project for later today, I suppose, for the evening, because we got the forward pass at a decent speed. Now it's just up to me to get the backwards pass, but this is still good progress. I'm gonna go get myself dinner in a second here. For folks watching though, I will be back in probably 45 minutes ish. Medium length dinner today. If you're interested in all of this generally, this is all going into the next update. The goal is to have much faster training, faster sweeps, faster everything. It's all on puffer.ai. It's all open source. Start the GitHub. It's free. It actually helps me out more than you'd expect. Everybody's on the Discord. This is where all the dev happens if you want to get involved. And you can follow me on X for more content, including my educational articles and my research posts. I will be back right after I get some food because I am starving. I'm hoping that we get at least a full prototype of this done today that like has a reasonable speed and that I can be happy with like the end-to-end thing that if I maintain most of this speed, we should be able to break like 10 mil steps per second. That I'd be happy with. All right, back in a